Before we begin tonight's proceedings, I would like to acknowledge that we are meeting tonight on the traditional land of the Binjara people and pay our respects to their elders past and present. We wish to acknowledge and respect their continuing culture and their contribution that they make to the life of the city and the region. As you already may know, with us tonight we have special guest Mr. Aaron Tuckey presenting Welcome to the Anthropocene, an Introduction to Climate and Sustainability Science. Aaron is originally from Mandurah and he is currently completing postgraduate studies in sustainability science in Sweden. He also works as a researcher at the Climate Change Leadership Node and teaching assistant in sustainability at Uppsala University in Sweden. Today has been made possible by the Field Preservation Group. So Field Preservation Group, as many of you know, many of you members here today and have been for a long time, is an environmental group that has been operating for over 30 years, I believe, in Mandurah. Field Preservation Group originally approached us with the idea of presenting this talk tonight. Obviously Mel Tuckey and Aaron Tuckey being here with us. And they've also helped promote the event. If anyone is interested in joining the Field Preservation Group, we do have membership forms up the back next to the laptop. And just so you know, the laptop is showing some footage, which is about 30 years old, of how Mandurah used to look before we had some of the, prairie wetlands and sort of the houses go in. So if anyone was interested in looking at that footage later on tonight, that'll be on the laptop up the back. Without further ado, I would like to welcome Mr. Aaron Tuckey. Thank you.
Good evening. Thank you everyone for coming out tonight. It's a really good turnout. I'm very happy to see you all here. Can you hear me at the back? Okay, fantastic. All right, let's hope that this works. So, welcome to this discussion, this introduction to sustainability science and climate science. Welcome to the Anthropocene. You're probably wondering what this is. Don't worry, we'll be finding out what that is shortly. I'd also like to acknowledge the traditional land owners of this land and also pay my admiration to them, because Australia is a very harsh land and a very harsh climate. And I think if you put me out in the bush, I wouldn't last more than a week. But this land has been lived sustainably for the last 80,000 years. And I think there's a lot that we can also learn in the context of sustainability when we think about the traditional owners of this land and their custodianship that they have been providing over the last many thousands of years. So my name is Aaron. You may have noticed I have the same last name as the room in which we are gathered. That is a bit of a coincidence, but not that much. My family has a long history back here in Mandurah, tracing back to 1829 on the first boats that came out here from Europe. And I'm also born and bred in Mandurah, but the last few years I have been living, working and studying in Europe, specifically in Sweden at the Stockholm Resilience Center and at Uppsala University. So let's talk a little bit about how this is going to work tonight. So there are two presentations. The next one is in 2 weeks and 1 day from tonight. The focus of this presentation is going to be more about where are we now and how did we get here? And here's some of the questions that we'll be discussing. And then in the next session, so on Thursday, the 28th of February, we'll be looking more about where can we go from here and what are we doing about this? And an ongoing theme in both of these discussions will also be about trying to imagine new possibilities. So I'm going to try and make this a little bit locally relevant where possible, though my research basis isn't focused on Mandurah. And I'm also going to try and put in some of the Swedish perspective into this, because that's where I am working and studying at the moment. So what this discussion is and is not. So firstly, it's interactive and participatory. So if you do have any questions, put up your hand, especially if it's a clarification. I would want to clarify things immediately. If they're more detailed questions, we're going to have a question and answer period after the break. So we'll probably run now for about an hour in the presentation, depending a bit on if we get some discussion going as well. It could be longer or shorter. Then we'll take a break. We can grab some more food, tea and coffee, have a bit of a think about everything that we've discussed, and then we'll have some questions afterwards if you would like. All right? But if you need to leave at any time, then you're obviously very welcome to do so. in terms of what this discussion isn't, it's not a discussion on the validity of climate science. So in Australia, I actually had to remember to put something in my presentation for this, because in the Swedish context, climate denial is very much a marginal thing, if present at all, within the social debate. So I haven't actually been thinking about climate denial for quite a long time, but coming back to Australia, you can see that it's very present and that it's very real here. So of course, if for whatever reason anyone does want to discuss the validity of climate science, then stay back and we'll have a chat about that. But I don't think the majority of people did come out here tonight for a discussion on the validity of the science, so I would rather not take any of those questions during the group question time. But I would also like to point out that it's not that unusual that people deny science. If we think about it in a historical perspective, when we discovered that the world was round, there was a lot of reactions to this. But even the theory of evolution is still denied by many, many, many millions of people around the world. And this is 150 years after that. So it's not unusual that people deny science. The problem, of course, with climate science is there's very practical consequences of denying climate science in relation to, for example, the theory of evolution. But remembering also that climate science is a product of the scientific method that already has peer review, that already has mechanisms in place for a debate when there's a debate to be had. So denying science, denying climate science in a way is also denying the scientific method. So I think it's important to reflect upon that. I know I've got a lot of introductory slides and you probably want me to get into my substantive content, and I will do that shortly. This is just one last point. You're probably wondering a little bit about why I am doing this presentation. So when it comes to climate science and sustainability, there's a lot of finger pointing, but there's also a lot of ignorance. And people often look to the experts to solve everything. The problem is a lot of experts have also gotten us into this problem. So I think that a more important question is about what you do with the knowledge that you have. So I'm no professor. It'll probably take me maybe another 20 years before I become a professor, who knows. But I realized that I began to know a lot more about this topic and realized a lot of the consequences of that research quite immediately, and thought things need to be done now, and I'm going to do whatever I can with the knowledge and research that I have already conducted, because we can't wait another 20 or so years. So then, in terms of for you guys, the reality is most people don't know very much at all about climate science. On a global perspective, a lot of people don't know anything. But even, I would say, in our society, a lot of people have heard the term, but they've not engaged with it very deeply. The fact that you've come here tonight means that you probably already know probably more than the average citizen. And after this presentation, you'll probably know quite a bit more than the average citizen, because most people don't sit through climate presentations. So you're probably going to know more than the average person, if you didn't already. So, and if you agree with any of the stuff that I'm saying, then what actually happens is you've actually taken on a bit of a special role here. Because if you take these issues seriously, you begin to realize that most people don't know much about this. And maybe you will also want to share this information with others in the way that I felt compelled to do so. So let's move on. What I'd like to do is start with a little bit of an interactive exercise. So I work at a place, I work with Education for Sustainable Development, and we often like to do more interactive kinds of learning. So I wanted to mix a bit of this into my presentation. So what I actually want to do is a bit of an imagination exercise. And I'm actually, to facilitate this, going to ask you all to close your eyes. You'll have to trust, well, you don't have to trust the person next to you. I'll have my eyes open, so don't worry, no phones will go missing. Just close your eyes, and I want you to imagine. I want you to start by imagining the first seed that was ever sowed by a human being who planned to watch it grow and harvest it. So keeping your eyes closed, imagining this first person sowing and harvesting a seed, remembering that we haven't always done this. Then I want you to imagine the first harvest, the first real harvest that we had as a human race, and when we shared that with our families. I want you to imagine the first permanent home that we built with the expectation and the hope to survive through the winter. And I want you to imagine when we left hunting and gathering behind, built cities and towns, and created things like non-portable art and architecture and writing systems. And then the development of more modern technology, of trains, planes, computers. And finally, I want you to open your eyes and look at everything in this room and compare and contrast that to the world of the hunters and gatherers. What you have just done, you've imagined the entire Holocene, the entire period of time that we call the Holocene. Has anyone heard of this term before? Yes. It's not just a song by Bon Iver, it's also a geological time period, which looks a little bit like this. This is our last period of time called the Cenozoic era. The Holocene is about the last 12,000 years. But I want to look more specifically at the climate of the Holocene. I don't like to use too many climate graphs, because everyone likes to show a different graph that can do a different thing. But I wanted to just look at the Holocene itself, the last 12,000 years, which has been a relatively stable period, climatically speaking, in the Earth's history, and the period of time when all of these developments have occurred. Is there anything that catches your attention in particular about this graph? Is there anything you'd like to comment on that you find interesting or strange? Just put up your hand and have a go. Yep.
A couple of small things and then the modern thing.
Okay. Yep. Very good. Is there anything else anyone else would like to add?
Little ice age.
Little ice age. Yep. Anything else?
But it all occurs within a range of just a couple of degrees.
Yep. Another really good observation. What catches my attention about this? We often look at this, we often look at this, but I'm pretty curious about what this is. This is a really big change, and it all happened just before the Holocene. So we're going to go back a little bit more in time and have a look at what's going on there before we continue. So now we've got the last 100,000 years of temperature variation. And this period up here, this is all the Holocene, all right, the last 12,000 years. If we go back though, we can see that the Holocene is a very rare period, speaking over the larger historical timeline. It's not at all the normal state of the Earth. The normal state of the Earth over the last 100,000 years has been very sudden climate fluctuations. And during all this period of time, humans were hunters and gatherers, and for much before that as well. And at times, this was quite difficult. At times, the human race nearly went extinct. Humans have flourished in the Holocene. And we talked about when agriculture took off. We talked about the planting of this first seed and this first harvest. Does anyone want to have a guess when that occurred? It occurred somewhere around here, just at the beginning of the Holocene, around 12,000 years ago. So we begin to see two things from looking at this. Firstly, that the Holocene is a very rare state of the Earth in terms of the larger picture of climate variability, but also that agriculture coincidentally, or we could say as a result of, took off and began and took off just the commencement of the Holocene. We go back to this graph again now. Now it's interesting to look at this other side here, because a lot of the temperature models that we talk about over the next 100 years are looking at 1.5, 2, 3, and 4 degrees. Right? So we're looking at changes like this. Remembering, of course, that here we're looking at hundreds of years, and here we're looking at thousands of years. All right, so all changes in the yellow part of the line here are 10 times more exaggerated than the ones here in the blue line. All right, so it's a very sudden and potentially large change that we're seeing here. And it also means that we're leaving this stable climatic period of the Holocene. We're not within the range that the Holocene has been for the last 12,000 years. Which begs the question, where are we now? We're not in the Holocene. Where could we be? Does anyone want to have a guess? The Anthropocene. It would be a pretty useless title for my presentation if I didn't mention that somewhere. So, welcome to the Anthropocene. So when we divide these different scenes, the Holocene, the Anthropocene, what we look at to define them are global scale changes. So you might have heard of the Jurassic era with the dinosaurs. This period of time came to end with the giant meteor hitting the Earth, right? But other things like prolonged volcanic eruptions or the movement of continents are also the kinds of things that define the changes in this historical period. The Anthropocene is a term that's becoming more and more used to describe the way how humans are now the drivers of global changes. And here I'm not just talking about climate change. So I'm talking about atmospheric, geological, hydrologic, biospheric, and other Earth system processes at the global level are now all being significantly altered by humans, to the extent that human activity on Earth will be visible in many millions of years into the future, in many different ways, all right? Maybe not all of them bad, you know, but it will be very visible, is the point. And I think that it's pretty clear when we look at the Earth by night, how different that Earth looks from the Earth that we saw, you know, several hundred years ago by now. So here, anthro means human, and scene is just the suffix that we use to describe periods of geological time, the Anthropocene. Okay. So there's many different ways that we can visualize the Anthropocene, and I'm going to take a few minutes now to go through a few different ways of doing that. I firstly wanted to start by looking at this phenomenon called the Great Acceleration, which basically demonstrates that there's been exponential growth in a whole series of socioeconomic activities with resultant effects on trends in the Earth system as well. So these begin from around the mid-18th century during the Industrial Revolution, but really take off from 1950. I know it's a bit hard to see, but 1950 is this red number here, all right? And in all of these, the first one is 1750. So human population is a pretty obvious one. We can see that in places like Montreal, for example, where we're now approaching 100,000 people. But human population growth has had lots of flow-on effects in terms of economic activity, things like here we have paper production, international tourism, but also what's driving all of this, so like fertilizer consumption and the production of energy and the production of food. Basically anything that you can think of is following a lot of these trends. So number of McDonald's restaurants will conform to this trend. Number of roads built will conform to this. Okay, number of water bottles, plastic use. They're all following this general hockey stick shape. But this has a lot of effects on the Earth system. So we hear a lot about carbon dioxide, but also nitrous oxide, methane emissions, also the acidification of the ocean are all following these kinds of trends. And the depletion of the ozone layer was also following this trend. That's flattening out of it now, fortunately. So by pushing and by growing at the rates that we are growing, we can see that a lot of these trends are taking off and they're having consequences for human activity on Earth and the biosphere, which allows that to happen. But I want to look at the Anthropocene from another perspective. One of these here is also loss of biodiversity. And I think that this is pretty well graphically explained by just if you got all the land mammals on the Earth, so including humans, and line them all up on some gigantic scales and weighed them, this is basically what it would look like. All right, and I think this is quite interesting because humans are now 30% of all land mammal mass. So land mammals includes obviously all your primates, all of your big cats, all of the African wild game, all of your Australian marsupials, and Australian mammals. These are all mammals, all right? So humans are now 30% of the mass of all mammals. But what's interesting is all of our pets and livestock make up the next 67% of all land mammal mass. All right, this one here are just cows. All these are just the mass of cows. All right, here we've got sheep, horses, goats, and pigs. And we don't have that many breeds of a lot of these different animals as well, all right? Obviously, there are different species within cows and goats and pigs, but not as much as the natural biodiversity because for agricultural use, we want the same species generally. So what's left is now only less than 3% of wild animals. So you can see this one square here is elephants. And I'm not sure what these other ones are here. But they would be things like your big cats, your primates, your mammals, and your marsupials. But then there's one last way. And of course, if anyone has any questions about any of this, I'm aware I'm moving quite quickly through this. So if you do have any questions, please put up your hand. but if not, the last way that I wanted to try and visualize and understand the Anthropocene is by talking about one of the stories of what happens when we conduct global level experiments on the Earth. Does anyone know the connection between these two images? Yeah, the ozone. Yeah. So I think in Australia we're all pretty aware. You need to put on your sunscreen. The ozone, the hole in the ozone layer affected Australia more than other places. So we're pretty aware of the consequences of this. So we've had probably the story. We developed refrigeration technology at the beginning of the 20th century using fluorocarbons. These leaked out into the atmosphere and started to erode the ozone layer, causing a hole over Antarctica every spring, which means that more UV light comes in and we get burnt. UV radiation from the sun is very, very potent, and the ozone layer is very important to protect us. Without any ozone layer, UV radiation will probably make all life on Earth, all life on land on Earth, near to impossible. Under the sea, it's a different story, but on land, the ozone layer is what allows us basically to survive. So what happened is that we noticed there was a problem. All the countries came around from the world and signed something called the Montreal Protocol. And obviously they accepted the science in doing so, and they began to reduce and change their technology, and the hole in the ozone layer began to repair. And so we avoided this problem. So that's the first story that I wanted to say about the Anthropocene. That there are global challenges, but there are also global solutions. We have all the political mechanisms in place to be able to take action on these kinds of issues. There's a few hidden stories behind this, which I also find just as interesting. So this was picked up over Antarctica in the 70s. At that time, there were two research stations, or two major research stations who monitor ozone. There was NASA and there was the British Antarctic mission. So NASA, in monitoring the ozone and many other things whilst they are stationed in Antarctica, decided that, well, we've set up all these computer programs, but we don't want any wild values coming out of nowhere and confusing us, confusing the computer programs. So we're going to set some parameters from what data the computer programs can show us. And they basically said, we don't want the computer program to be able to show us anything that is deemed impossible. They deemed the destruction of the ozone layer impossible. And so NASA did not register the destruction of the ozone layer. Luckily, the British didn't do this. The British realized what was going on, and they sounded the alarm, which was then later verified by others, and then we took action on that. So again, if we're blind to what could potentially be going on, we won't see the consequences, perhaps before it is too late. So it's important not just to hope, but also to be very aware that we are, by emitting what we are emitting and by making huge changes in many different Earth system trends, we're conducting global level experiments on the Earth. We just don't know all the time how it's going to react. So it's important to be aware. But one last story about this. You'll soon see why I chose this example. There's lots of good stories. When we were developing refrigeration technology, so we needed some kind of coolant gas that can carry hot and cold at the back of your fridge that goes through these pipes. When they were starting to develop this, there were many different options. So we used something based on chlorine, but there was also bromine and many other different chemicals that you could put in the system. Industries like standards. We like industry standards. We like one way of doing things. It makes it easy to repair things. It makes it easy to teach other people how to do things. So the industry adopted a particular standard, and in this case, they adopted chlorine as the basis for refrigerant gases. However, there were alternatives such as bromine. Bromine has probably roughly equally the same capacity to do what chlorine does in terms of refrigerant gases. Bromine also erodes the ozone layer, just like chlorine does. Except bromine erodes the ozone layer at a rate 50 times more potent than what chlorine does. So if for whatever reason we had chosen bromine as an industry standard, it could well be that the ozone layer, the hole in the ozone layer wasn't just a once-a-year event over Antarctica, but rather global and the whole year round. Because at that rate of erosion, we might not have picked it up in time. So again, we need to be careful when we conduct global level experiments on the Earth. We don't know what is going to happen. And of course, bringing this back to climate change, which I know a lot of people wanted to hear about, here you can just see basically carbon dioxide levels and methane levels with temperature levels here. So leaving aside climate change, if you just look at the levels of carbon dioxide, they're the highest they've been in 800,000 years. And methane, I haven't got the figure, but I think it's several millions of years that methane has not been at this level before. So the normal range here being between 180, 280, and now we're above 400 parts per million of carbon dioxide. Methane, this is the same scale. So methane here is 400 to 700, but then goes all the way up here to 1800. All right, so it's just the way they've arranged the scale. So methane has gone up a lot. And methane is also a very potent gas for global warming. It's about 30 times more potent. With methane, though, it dissolves in the atmosphere, or it breaks down after about 12 years. So it has a short life in the atmosphere, but it contributes a lot to warming during that time that it's in the atmosphere. Are there any questions at this point? Okay. I think we've seen these kinds of graphs before, so I just put this in here to refresh our memories. I didn't want to talk too much about it. But then I'm living, working and studying in Sweden. And a lot of people think, okay, maybe Australia's not doing a lot, but Sweden's doing better, right? And it's not that simple of an answer, actually. So to answer this, I'm firstly going to look a little bit at different ways that we measure emissions. So this is basically global emissions assigned per country, territorially speaking, which means all the emissions in a particular country for that particular year. All right, so this is the year 2016. So you can see the countries we normally talk about: China, US, India, and Russia. Australia's maybe somewhere in the middle. Sweden's, maybe on the lower end. But of course, this would be on the assumption that each country has the equal right to pollute, because this is assigned per country. This is the number of emissions per country. But a more realistic way, a more fair way of looking at it is about that each person would have the same right to pollute. And that would mean looking at emissions per person in each country, if that makes sense. So obviously China has over 1 billion people, Australia only has 25 million people. So if you think about it per person, we start to get a bit of a different picture. Some things change and other things don't change, but quite noticeably Europe goes quite up a bit, parts of the Caribbean, China and India go down a bit. Sweden's creeping up quite a bit, and it's already looking quite similar to China. So, and Australia is now ahead of China when we look at per person emissions. But again, it's all about the way that we measure and count, and the way that we do accounting. Because again, territorial emissions still just means the emissions that are happening within Australia. But now we live in a globalized world. So we used to have a lot of car production in Adelaide. We used to have a lot of Holdens and Fords coming out of the manufacturing plants in Adelaide. But slowly they have been closing down. We've been moving into more services in our economy. And we've been importing cars from South Korea, Japan, China, and other parts of the world. So these cars, for example, just going with this example of cars, these cars are produced in those countries, and the emissions associated with that production are assigned to that country. Excuse me, under the previous model that we were looking at. But this car then comes to Australia and lives its whole life in Australia, drives around Australia for the benefit of Australians. So we're kind of causing those emissions in China because we want to be able to drive around in Australia. If we instead made these cars ourselves, we'd be emitting more, obviously, because we would have those emissions happen in Australia. So there's another framework of emissions called consumption-based emissions. So assigning the emissions to the person who's the end user, the person who's driving the demand of that product. And you can probably guess where this is going. We get a bit of a different picture again. So we see that we've got a lot happening now in Europe. Some of these small states in Southeast Asia are going up quite a lot, but China and India are about the same. North America and the Caribbean are going up, and so is Australia going up. So Sweden is doing okay, perhaps. It depends on what your reference point is. Sweden has a very low energy, what can I say, a low emissions based energy sector. So they have a lot of renewable energy and they have a lot of nuclear energy. So emissions associated with energy production are quite low. They also have a service-based economy. But Sweden is driving a lot of emissions in other countries through import substitution. They're importing things rather than producing them themselves, all right? And Australia is doing this as well. But continuing with Australia, here we're ranking about number 11. So if we just get rid of the other countries, this is just Australia and the countries that are emitting more than Australia. So it's about your top 11 countries. But in this, we have some small countries like Luxembourg and Brunei. When you have a small country, you don't have the big working class who bring down your average of emissions. So if we get rid of countries with less than 1 million people, we end up with this club of countries, which is now less than 10. So we have Australia, Singapore, your petro states in the Middle East like the UAE, Saudi Arabia, Bahrain, and Qatar. Belgium is the only one in Europe, and then the United States and Canada. This is based on consumption emissions per capita. So we already did answer this question a little bit. There are good things that Sweden are doing, but of course, there's other things where more action needs to happen. And Sweden very proudly says that we've reduced our emissions by quite a lot in the last 20 years. But when they do that, they're counting their territorial emissions. They're counting the emissions that happen within the borders of Sweden. When you include consumption emissions, when you include aviation, so flights and international shipping, Sweden's emissions have not changed basically in the last 20 years. They haven't gone up nor down. And countries like Norway have had their emissions going up on that accounting mechanism over the last 20 years. So it's a lot about also your PR. It's a lot about the way you're selling your action, all right? Because yeah, Sweden's reducing its emissions, its territorial emissions, but that's because it's getting other countries to produce goods and because they're not counting flying. And flying is quite a big deal because it happens at the international level. So when we're talking about international flights, no one is really claiming responsibility for these. They're given to an international organization that doesn't really have any mandate or power to do anything and has no plans to reduce its emissions. Globally, aviation emissions are maybe about 4 or 5%, but flying is very much a Western developed world phenomenon. So in countries like Sweden, it's more like 20% of your emissions are coming from flying. And this is kind of problematic because it's also one of the hardest things to substitute for something else. So we have pretty good developed electric cars and electric trains, all right? We can see a potential future. Electric flights is something that is very far into the future, if at all possible. It's not something we'll be substituting anytime soon. So flying is also a really important thing to consider, especially because so planes emit emissions at the upper atmosphere, which has a further warming effect. Okay, it's about 2 times the effect if you emit at the higher parts of the atmosphere. All right, that's getting a little bit technical. Let's take a break. Why does this matter? Does anyone have any reflections at this point? I think we might generally have some concerns. Why does this matter? Well, I would say it matters, perhaps, because we don't insure our home or our car with the assumption or with the expectation or with the hope of it being burnt down or stolen. Right? No one wants that to happen, but we insure it anyway. Might be a 1% chance that happens, but we do it because we don't want the worst to happen. So this is in line with something called the precautionary principle. We take action now to a certain extent to mitigate for any potential negative consequences coming in the future. The reason we have insurance. So, for example, if you were to board a flight and I was your friendly flight steward there to greet you at the door, and I say to you, look, sir, madam, unfortunately, it looks like our engines haven't been working as good on the previous flight. We've been trying to improve this, but we can't 100% guarantee that they'll work. So we think we've got an 80% chance that the plane's going to arrive at the destination. But that's an 80% chance. That's fantastic. So welcome on board. Here's your seat number. Would you get on the plane? I wouldn't get on the plane if someone said that to me, if it's an 80% chance. But what if they said, no, but no, we've been working on this issue, we're taking it very seriously. We've reduced it to only a 10% chance, okay? A 90% chance you'll arrive. Is there anyone who would board this plane? Okay, and it goes on for a 5% chance, a 2% chance. Most people don't like even a 1% chance of going on a plane that's not going to arrive. We don't like these risks. We especially don't like them when they're direct, personal, and clear risks. And with climate change, unfortunately, a lot of those risks haven't fallen into that category. But this is something that may change in the future, but regardless, there are risks. They are quite significant risks. All right, so that's my little would you exercise. I know that I would. So a lot of these risks that we're talking about are non-trivial risks for non-trivial global processes. So a lot of scientists have come together and put together something called the planetary boundaries, and these are considered a safe operating space for humanity. And here you can see that we're not just talking about climate change. So there's lots of other environmental issues to be aware of: ocean acidification, biosphere integrity, so that's genetic diversity, so biodiversity. These ones are like fertilizer use in the water, nitrogen and phosphorus, land change, and so on. There's a lot of global Earth system processes that scientists have considered are vital for us to be able to live the way we're currently living, and have also set up basically some thresholds for where we think we shouldn't go beyond that. Some of them are going quite good, others not as good. Climate change is beyond the boundary, the safe boundary, but it's not as far out as, for example, biodiversity loss and fertilizer affecting the oceans. So I won't go into this into a lot of detail, but what I just want to take home from this is basically that there are certain points beyond which we don't know how the Earth is going to work. If we push the Earth or Earth processes into too much of a corner, how they're going to react. One example that is talked about a lot in Mandurah, sea level rise, because Mandurah is very low lying, and I'm sure you've probably seen some of these graphs before, 1 meter and 6 meters rises. If you've ever been in a white or a black car in summer, you'll notice there's a really big difference. The black car is always much hotter because the black car absorbs a lot of heat, whereas the white car reflects the heat and the white car is cooler. So I'm sure a lot of people have experienced this. If your friend's got a black car, you go into their car in summer and you regret doing so. The same effect happens on Earth. So at the poles, we have a lot of white ice, which is reflecting a lot of the light back into the back out to space, basically. But as ice melts, it turns into dark blue water, which then absorbs more heat and causes more melting. So the problem with that is it creates a lock-in. So that's why we talked about these boundaries, because when you go too far, your system changes and you now have new feedbacks. So now your water will absorb the heat and keep the Earth even hotter, which means that if you want to go back to cooling down the Earth and getting back your ice caps, you're going to have some giant white canopy around the whole Arctic Ocean to reflect the light up to get the same effect of what the ice is currently doing, right? And there are a lot of geoengineering projects like this that are being researched. How can we cool down the Earth in other very expensive but perhaps necessary ways? Things like painting deserts white, just as ways to reflect heat, all right? It's not easy to go back once you cross certain thresholds. But whilst we're on the topic of Western Australia, I would just see what they're saying will likely be some potential effects in Western Australia. And like in much of Australia, it's basically more drought and more fires. And these also have lock-ins. So the more warmer it gets, the more fires you have, the more you burn trees and release CO2, the warmer it gets. So new feedbacks. Another one also with drought is when the soil gets really dry, you can't retain water. It's like sand. So when the rain finally comes, it just goes straight through and into the aquifers. It's no longer able to absorb the water. All right. If you've got an old neglected pot plant, you'll notice this phenomenon. All right. Sure, we've all got one of them. If you pour water into it after having not watered it for a very long time, the water just goes straight through. It's not going to stay in the soil. Okay. So what we're getting at here is basically you have different systems with different lock-ins. All right, and we often have this ball and cup diagram in sustainability. So you've got a ball here, and you need to think, obviously, it's like gravity pulls it down, and it's just going to sit in this little slopey area here. All right? You might change a prime minister, you might change a tax, so you'll move it around from left to right. It might go up here, it'll roll back down. It might go up here, it'll roll back down. All right? But then over time, what can happen is this can become eroded, all right? If we keep making incremental changes to systems, it weakens this and this will start to erode. Or if we have a giant shock, we might hit the ball really far, and then what happens is it rolls into here. And then again, you can change your prime minister, you can change your tax, and it'll roll up a bit, but it'll keep rolling back down into this system here. All right, the images in the background are of coral reefs. This is a coral-dominated state, and this is an algae-dominated state. So it's an example of how we can go from one system to a different system. And this is what happened in the Caribbean in the 1970s. So over time, so there's always hurricanes in the Caribbean. And when the hurricanes come, it kills a lot of fish, but the fish come back and the coral comes back. But over time, through overfishing, because fish play a vital role in keeping corals there. But over time, through overfishing in the Caribbean, this got weaker and weaker. And then in the 70s, there was a really big hurricane. And then suddenly, it just went over here. And the majority of Caribbean coral reefs became algae dominated. And it's very hard to get that back because certain fish can't live here, and then they also can't foster the environment needed to go back. And of course, ecosystems change, but we need to remember that humans are a part of these ecosystems. So over here, we're getting a lot of fish, we're getting a lot of food, we're also getting a lot of tourists. Here, we're not getting a lot of those things. So it's important to also manage for the kinds of systems that are friendly to human life. All right, the algae is having a great time over here. Algae thinks this is great, all right? But in terms of what it provides to humans, it's not the same story. Okay, I've been talking pretty fast. I go from talking very fast and intense about science to slowly and reflectively about other things. And that's what we'll do now. So we've talked a lot about ecology and the environment, but of course sustainability is also about better outcomes for people. It's about health, about well-being, education, gender equality, and so on. So these are also very important goals. Goals are important. So some scientists, and I'm sorry for, I think this is my last confusing looking graph. Some scientists came together and they put together these boundaries that we talked about. So climate change, air pollution, okay, land conversion. All right, the names are a little bit different, but it's the same thing. But they said, but that's not good enough because we also need to think about housing, about water, and about health. So it's not just about exceeding these boundaries, which they call the ecological ceiling. It's also about bringing us up to a social foundation so that we can live prosperous and happy lives. So here we're falling short, and here we're overshooting. In this green area here in the middle, this is called the safe and just place for living, all right, and for organizing our societies. All right, it looks a bit like one of our favorite desserts. And so they've actually given this the name Donut Economics, all right, which is actually a really good book. I would recommend. There's a lot of things to learn from that. So how can we keep within the donut, they say? But more than the donut, what interests me about the name is the emphasis on economics, because we start to realize that this is basically about the art of managing resources and the art of trying to maintain societies within certain boundaries. And this has a lot to do with economics. We know that we're not allowed to run economic deficits, or so we are told regularly. But if we think about the Earth as a bank account, each year the Earth produces resources for us. So it produces new clean air, it produces timber, clean water through rain, produces food. The Earth is producing resources, and we as humans are consuming those resources. We're eating them, or we're drinking them, or we're building with them. Okay? The Earth ecological, what is it called? The overshoot day is basically a way of trying to show how we're now consuming more resources than what the Earth is producing. So if X number of resources are produced in the year 2018, throughout the whole year, the human race has already consumed all those resources by August 1. Okay, now that sounds weird. How can we consume more than what is being produced? That doesn't make a lot of sense. Well, that's because we didn't start with nothing, right? It's not like we're starting with a bank account of zero. We're starting with a bank account with X amount of money. We're gradually withdrawing more than we're putting back in. We're gradually consuming more resources than we're allowing for the Earth to produce them. So we're going into a bit of a debt. This, however, isn't homogeneous around the whole world. So different countries are doing things differently. So if everyone in the world lived like China did, their overshoot day would fall on the 23rd of June. So a little bit earlier. So that would be if we had 7 billion, Chinese people instead of 7 billion global people. It's if everybody lived like the average person in China did. If everyone lived like the average person in Honduras did, we wouldn't have that much of a problem because we'd only consume the amount of resources that are produced by the last day of the year, okay? But I'm not so sure about standard of living in Honduras. Australia comes in here. If we had 7 billion Australians in the world, we consume all of the Earth's resources by the 12th of March. So that's only 1 month away. And then the rest of the year, we'd be living on borrowed resources. Or rather, we'd be chipping away at the resources the Earth has. Obviously, that can't go on forever, because then there won't be any resources left, right? We can't go that much into a debt, because unfortunately, the Earth doesn't work exactly like a bank account does. Another way of looking at this is how many Earths you would need to sustain the way that we're living. And again, unfortunately, Australia doesn't unfortunately do very good at a lot of these graphs. I'm sorry, I don't want us to feel bad about being Australians, but I think it's an important point to highlight. The world average is 1.7. So around the world, generally speaking, we're consuming more than the Earth is producing. India, interestingly, is actually below that threshold. So, where does that leave us? Well, it basically means that we're running an ecological deficit. And we're often told we're not allowed to run economic deficits. They're not good for the economy. But we're running a pretty big ecological deficit. Like I say, it's not spread evenly across the world, even across our own societies. If we return to carbon dioxide emissions, the richest 10% of global citizens are responsible for about half of all emissions, which is actually a staggering figure if you think about that. Whereas the poorest 50% are only responsible for around 10% of emissions. And again, of course, we're looking here at consumption-based emissions, so people who are causing the production of goods and the emissions associated with that. So, but that's actually quite interesting, because that is actually a really good leverage as well for change. If we think about it this way, if the top percent of emitters reduce their footprint to their average European citizen, so not the average citizen in Honduras, or they don't need to disappear entirely. If they reduce their emissions to that of the average European citizen, whereas the other 90% did nothing whatsoever, we immediately reduce global emissions by a third, which is quite a significant amount. We're probably wondering who these top 10% of people are. Unfortunately, it's not just people like the Kardashians. And this isn't something that I'm going to go into a lot of detail, but we generally know the kinds of things that are emitting behaviors. And so, for example, people who are frequently flying, like I told you, flying is actually a really big cause of emissions, especially because in the upper atmosphere, it has twice the warming effect, would also fall into these top 10% of people. So you and I, it could be people, some of us might be falling into this category, all right? Not just all of the Kardashians. But we were discussing how this is an art of economics in a way, trying to manage the resources that we have. And so then I asked the question, well, what is our economic goal? We talked about the goal of fitting in the donut. This unfortunately isn't the way that the majority of people look at resource management and economics. So what is our economic goal? Does anyone have any proposition, any idea, any suggestion of what that could be?
Debt-free.
Sorry?
Debt-free.
Debt-free? Yeah, that's true. Anything else? Well, I'm not an economist, so I'm not going to tell you all the answers to this one, but I think a good indicator is what we measure. The thing you measure a lot is what you probably care a lot about. And the thing that you compare with other countries and compare to what you had last year is probably what you care about. And that seems to me to be GDP growth, so economic growth. So the growth of all productions and activity in the economy. And we're often told that, that GDP growth is good, that economic growth is good, and so on. But remember here that that's implying that economic growth in itself is a goal and not a tool for achieving another goal. All right, economic growth is obviously a tool to do certain things. We need to grow the renewable energy sector. We need growth in that sector if we want to reduce carbon emissions. That's economic growth as a tool for a different goal though. But often we get confused, I would suggest, and this is open to debate, but we seem to get lost and think that growth in itself is a goal. This is a little bit problematic, and this is a little bit oversimplified here, but just to illustrate quickly, a lot of things that are good for the economy aren't good for society. So if we eat unhealthy, if we eat a lot of bad food, and then we need ongoing medical care and we need more pills to correct for our bad lifestyle habits, or if we're feeling detached from society and we take more pills to make us feel better about ourselves, these things are good for the economy because we're producing more things, we're consuming more good things. But the problem of feeling detached from society or from unhealthy eating habits, I wouldn't say is good. And it would be better to stop these things from happening rather than having consumption-based solutions. The other problem with growth as a goal is that things that don't produce anything, according to the standard economic accounting, aren't considered good either. So if we just do a lot of voluntary work, this doesn't really register as improving economic growth, even though it's improving social capital or perhaps environmental capital. If it's not contributing to growth in an economic sense, then it's not considered good. My image here, yeah. But I don't want to just sound like I'm saying growth is bad, growth is bad. I mean, this would be interesting to have a discussion around. Growth is something that is very natural, of course, and it's something that occurs in nature all the time. Things grow like trees, but then they reach maturity and they stop growing. If things grew forever, we'd have a pretty strange looking planet with some pretty tall trees, I would say. And I don't think it would last very long. Things reach maturity, but do economies reach maturity? This I don't know. The UN came up with 17 sustainable development goals. All right, and a lot of these feel good, happy goals, I think we can all agree with. Yeah, education sounds great, clean water sounds great, good health sounds great. But again, I fail to understand how economic growth fits in as a goal on its own right, especially as a sustainable development goal. Okay, growth is difficult to sustain indefinitely. All right, we'd like to think that new technology and innovation means we can always sustain growth forever, but it's pretty hard for anything to be going through exponential growth continuously, right? Because constant growth rates, whether they increase or not, lead to exponential growth, right? So if we have all of these other things, then I wonder, do we need economic growth? Maybe it's a tool, maybe it's a part of this, maybe it's really, really important, but I fail to understand why it's actually a goal in its own right. All right, so it seems like we've decided our tool before looking at the problem. When you have a hammer, everything's going to look like a nail because you want to use your hammer to solve all your problems, all right? So it's like we're blind to better options because we're very focused on our current goal, all right? And that's interesting because treasurers and finance ministers often have like a mini veto power in cabinets, like the prime minister. If it's not good for growth, if it's not good for the economy, the treasurer has quite a big say over this, right? And policies must be good for a growth agenda. Another issue with the science and economics debate is highlighted in the way last year, the Nobel Prize for Economics was won by an economist who works with integrated assessment models. And his take on climate change, actually he won the prize for working on climate change economics. And his suggestion is basically that the most efficient outcome is that we aim for 3 degrees of warming. Then we get the right balance of economic growth and also climate action. The problem with this is that 3 degrees of warming might not actually exist. If we aim for 3 degrees of warming, we might have already set the path for a different trajectory that will cause further lock-in warming, which is why a lot of scientists are saying we need to limit it to 2 degrees or 1.5 degrees. Because beyond that, it just might go off on its own course and it might just keep warming no matter what we do. So there are different ways of looking at the world, and this is something that we are starting to see. So the Prime Minister of New Zealand has recently been talking about well-being budgets, right? Budgets that contribute to well-being, policies that contribute to well-being. So refocusing on what it is that gives us a good lifestyle. which growth in some sectors, of course, would be a tool to do it. So then I asked the question, what if we had a treasurer for the environment? What would that look like? Well, some of my thoughts is that a treasurer for the environment probably would say that ecological deficits are just as bad as economic deficits. Treasurer for the environment would say that all policies need to be good for sustainability rather than all good for growth. And because a treasurer should be someone who guards our treasures, right? Our treasures shouldn't just be the economy, but they should also be society and environment. Or at least this is my take on it. And I'd be curious to hear your thoughts about this afterwards. We're going to go shortly to a break. So now I have lots of question slides because I'm hoping to stimulate some thinking and some discussion to talk about later. So what goals should we organize our society around, if that's the case? We had a bit of a peek at the Sustainable Development Goals of the UN. And maybe there's other ones that are also relevant. Oh, and that brings us basically to the summary slide, all right? So what have we done today? Basically, we looked at the Holocene as this period of stability, climatically speaking, for the last 12,000 years, and which was also the period that allowed agriculture to begin, take off, develop, and flourish. Then we introduced the concept of the Anthropocene as a new proposed epoch where humans are now driving a lot of global system change. We then looked at a couple of frameworks for safe and just living spaces, so the planetary boundaries and donut economics. We then talked about the ecological deficit and then a bit of an assessment of our goals. Should GDP growth remain our definitive societal and economic goal? So I think we did that pretty spot on in about an hour. I just wanted to end with this quote before we go to the break. So at every level, the greatest obstacle to transforming the world is that we lack the clarity and imagination to conceive that it could be different. We talked about the NASA researchers in Antarctica who had their blinders on and didn't think that the reduction of the ozone layer was even possible. Our imagination says a lot about what we can do, what we can't do, but it also says a lot about what we can do. And so it's an effective tool for creating the change that we may quite critically need. So that's basically it in terms of what I'm going to say. There'll be a part 2 to this in 2 weeks and 1 day's time on the 28th of February, where we'll talk more about what are we doing about this and where can we go from here. All right, I hope I haven't brought us all down into a lull. I tried to do a bit of a pickup at the end there, but if you need a bit more of a pickup, come along to the next session and we can talk a little bit more about that. Tickets again are free. It's great if you can register just so we can plan seating and food. And if you come at 4 p.m, you can join us for the Mandatory Environmental Volunteer Action Committee meeting. And then this will go on straight from that at 5 p.m. If you have any questions, you can write them to me here. We'll also have some time for questions afterwards now, which I guess we'll take a break time and then come back afterwards and do some questions. If you need to leave, feel free to leave. If you have any questions in cyberspace, you can write them in the comments. And if not, thank you very much for coming. I hope that you've gained something out of the presentation. If you have, or if you haven't, feel free to give me your feedback and hopefully see you in a couple of weeks' time. Thank you very much.
Wow, wasn't that amazing? Thank you so much, Aaron. I think we all agree that that was a super awesome presentation. So yeah, just a reminder, make sure if you wanted to come along to that second session, we'll be here in 2 weeks' time, Thursday night at our NEPAC, Mandatory Environmental Volunteer Action Committee meeting. Aaron will be doing the second talk and finishing this one off. Please feel free to grab something to eat out the back while we have our break, and Aaron will be here to answer questions as everyone goes around and yeah, gets networking. So thank you everyone and have a good night. Thank you.
Thank you. Yeah, I thought it might be good because of course some people have like one-on-one questions, but it might also be good for
workshop.
yeah. But,
we can do that. Should I say we'll have like 5 to 10 minute break?
Yeah, just like
Yeah.
something like that.
All right, sorry everyone, we'll have a 10-minute break, and when you're ready, we'll all sit down and we'll have that discussion question at the time. So 10-minute break and we'll be seeing you again. Thank you.
No, that's okay. Yeah, maybe it would have been better to just go straight on, but I feel like people are probably getting a bit.
Yeah, no, it's going to have a bit of a 10-minute break. I'll let you know.
Yeah. Okay. Thanks, Danny.
Thanks, Dad. That was very good.
Thank you. What's your name, sir?
Rod.
Right.
Yeah.
Nice to meet you.
Yeah. Some really good visualizations too. I hope you don't mind. I took a few photos.
No, that's no problem whatsoever. Yeah.
If I wanted to get a copy of any of that, I just
Slides.
email you or?
Yeah, write me an email. I can send you a copy of the slides.
Cool.
No problem.
Yeah.
Yeah.
Very good.
Gladly.
Thank you. Very much.
Hi. Thank you.
I just got a quick question.
Yeah, sure.
I read in a science in Australia, talked about anthropocene.
Oh, did he? Oh, great. I mean, clouds do produce obviously heat coming in. The temperature went up when they grounded. Okay. Okay. I think I'd be curious to see the book that I mean, I guess the main point that I would make is that it's all a really complex system. So we have a lot of different things going on. And even if that happened as a result of vapor trails blocking radiation from the sun, the emission of CO2 is in the atmosphere. So I'm not saying that that didn't happen. I would have to look into it. But it still could be changing longer term climate stuff, even if it's that's actually okay. Yeah. What's your name, sir? Okay. Thank you. Thank you very much for coming out.
There you go.
Hi.
Where are you on the whole of the ozone layer?
Yes, sir.
The springfall
Yeah, so what I was reading is that it's got also to do with the circulation of air as well. And so at the end of the winter, basically in Antarctica, when the clouds go away, the lack of movement. I think it's very open up to something, and I think that means that it's really Oh, okay. Yeah.
we can't stop that. There is going to be
Yeah, so what I read is like, yeah, it is a combination of natural process with human interaction as well.
so the global warming
Yeah.
is going to be one day if there's no ice in Antarctica because it's a continent.
Antarctica.
It is a land-based with ice.
Yeah.
So, if there was no ice, there'd be no spring.
So your point being that
It's global warming. I know global warming is bad, but in this case, there's no ice.
yeah.
There'd be no spring.
Yeah, but I guess my answer would be that it is very complex. So, I mean, remember also that global warming is really good for places like Russia. Russia is quite good. They can get way higher agricultural yield. So,
When they spring.
yeah, yeah. So there's a lot of there's some good things, I guess. It depends on the perspective you're looking at. But the main concern with global warming is just that it creates more instability there, and it's going to make it's going to cost us to adapt basically to what's going on. And some parts of the world we won't be able to adapt. Some countries will have it better, some countries will have it better.
In Australia, we don't use CFC-based gases.
Exactly. So yeah, that was the point of the program. Help stop that issue.
Have you looked at Bhutan and their popular government?
Yes. Oh, I haven't.
Just come back last year was there for a month, and actually gave a talk yesterday to the Anthropocene group, who was talking to you earlier, about the 4 pillars of government, which is growth, and happiness.
Yeah.
So
I've heard about that.
So sustainable economic development only allowed if it benefits all. Cultural retention of culture, environment, right up there. So that you have their 4 pillars. They completely tick off
Yeah.
what we're doing, and their whole approach. Very, we need to put it very forward thinking.
Yeah.
It's quite amazing. So the very things that people value, what they value in their gross national
I just wanted to thank you for the talk. I just got a message to the guy back home that the chicken is actually.
Yeah, no worries. Thank you so much for coming.
No, I was just, it was a pity actually. I thought they were both on a Wednesday night. I went and double booked.
Yeah, unfortunately. So we were going to have them both on Thursday, but then we thought tomorrow's Valentine's Day and people might not want to come out on Valentine's Day. So that's the reason. The idea was they would be on the Thursday. So,
That makes sense.
yeah.
I just said to Jim, they asked, compel or high water, I'm going to be marching with the children on March the 15th in Perth. I've joined a Grey Power climate change Facebook thing group, and I thought, yeah, that's okay, we'll just drop. I'm happy doing that. Yeah. So I may end up enjoying it.
Have a look at it. Have a look at it.
Tell me about. I'm glad you come along, Caroline. I'm saying come along.
I was just saying, let's have a look at then let's have a look at Bhutan. I went to Bhutan last year and did the trek. They've got 4 pillars of their government. They measure growth, national happiness.
That's brilliant, I know.
So the very things, environment
Way to
is
go.
one of the pillars of the
Yeah.
environment. Economic, it's got to be sustainable economic growth. You can't just.
Well, Caroline Knight?
Yes.
Hi.
Oh, yeah, I always thought.
I sort of met you, but not.
Yeah, probably not properly. Properly. Then you're
No,
yeah.
that's right. So well done, Aaron. That's fantastic. Very proud.
Yes.
It's really good. The city manager is running the show and sponsoring it. That's
It's good. As they should be.
so it is.
As they
I
should
think.
be.
So yeah, the city manager gets a bit of kudos out of this too. So you can put that in your report, the environmental things you did in 2019.
We're good at doing some things, but we're not very good at telling people about it. Linda was just saying oh, you know, over at Binjara, they give a value for trees. And I said, oh yeah, we do that here, but we didn't tell anyone we do it.
Oh,
So you know, we actually give a.
could have put that out. Yeah.
You know, there's a lot of stuff that we're not very good at communicating.
You have a good environmental team though with Tani and Bonnie Beale and that.
There's excellent. They're excellent. No.
Brilliant.
There's good stuff there. But there's, you
Way
know,
to go.
lots of challenges. We still get people that write petitions to say, can you please remove all the street trees because they drop leaves.
So we can do.
We still get petitions from people that say, can you please remove all the street trees because they drop leaves.
Oh.
And I just kind of go,
Well, you can never please everybody. That's
I'm just going to go. No, you can never please. You can never please everyone, but you can give it a shot.
give it a good
The
go.
Seabin thing got a good play.
I did, yeah.
Got some good coverage on that.
Yeah, it was really good. It was on the Channel 7 News
Yeah,
on
excellent.
the Saturday night. I
Excellent.
think the Sky News are going to do a story too. So
Yeah.
it's good for PPG to get our profile raised a bit. So you know, I sort of joined about 2.5 years ago. It's
Yes.
almost flag.
Yeah. Yes.
So with people like Griselda and other people sort of retiring and moving away.
Yeah,
And almost
I just have a question.
without videos like coming in, sort of not having that way.
That's good. That's excellent.
You're still doing okay, driving and
Well, I've got this new gig, you know, I'm the chair of the Bill Harvey Catchment Council.
I know. Oh, yeah, that's brilliant.
And that's really,
You're the right person to join.
that's fantastic. So I'm really chuffed about that.
Yeah.
No, there's a lot of stuff, and it's just that getting the best.
It's fantastic to hear a general presentation.
Yeah.
I think the young
maybe do a talk at some high school.
Yeah, that's what I
Cover
want.
some of the environmental things.
Yes.
It's been something that's fine for me because the I'm going back up mid-March. So I have afterwards to see if we can coordinate that. But yeah, the younger people. So the
Like they're going off
environmentally aware.
They
Same as young
I think it's just
people.
been negative.
The eyes
And
of
it's gas tank.
people that
The other thing is that
someone's like
burning in
something like that.
Yeah.
You know,
I
when
saw that
people
CCWA
Right, yeah. Absolutely, yeah. Yeah, the opposite of preaching to the converted. The preaching to those who need a bit of a shake.
they were saying is that they have
Absolutely.
certain
Yeah, yeah. Well, I've only got to keep it through the time that he goes back to the doctor.
up to the
So we after
CCWA.
that, we'll always come back to
Yeah, they all I think it's no one takes responsibility for the microscopic things. They say, oh, it's so microscopic. But when you add it all up, yeah, you're right. Like, then it becomes a lot.
yeah, he's away. He's in Honduras. Another month.
the city manager very fortunate that you there, so we lost everything we do.
But I mean, at the end of the day, whatever method of construction we use, by 2050 we need to be zero. So it's an interesting technology, and we could invest in making it cleaner and better and greener. We could also invest in even better technology. We're going to build something here. It's not like, I mean, we have existing power stations. It's hard to turn them off. People don't like turning them off because people do jobs and so on. But with upstart things like fracking, I mean, there's just no point in doing that. We have to try to make sure that we don't have people paid. I think we're going to have some questions.
One thing that's really but there's a lot of sort of sub-uses that it moves into another group.
Yeah.
Very happy if I got it. I know what you mean, but that really fast.
Yeah. We can ask other people to see if they're interested in that. But I think I'm going to just go grab Tanya and take a lot of things that I want. Okay, good to see you.
What do you recommend? Yeah.
Doing some decent work and some other. I probably do work.
Yeah, good. Well, I
Well, I guess we'll start a bit of the discussion now with the question and answers. So, if anyone's got any questions, just pop your hand up and we'll get the discussion going. So, thank you.
So this is a very informal environment. So if you do want to go and just grab some food or grab a coffee, move around, then that's fine. Right? And if you need to leave, then you can also just leave. But I think it's really important to have space for a conversation after a presentation. I'm no knowledge dictator or knowledge owner. I think we co-create knowledge and we co-create ideas. So I like to always re-engage back. So I've asked a number of questions to you guys as well. Feel free to pick up on any of them. But also if you have any questions based on what I have been saying or questions on other people's perceptions of anything, then I'm very happy to open this up to any form of discussion and just let it roll. Probably won't go on for too long, but just to get some feedback. So were there any questions or comments or, yeah?
I was wondering why Australia was the top of the list of the baddies, but we were talking about everybody seems breeders because of the huge distances that we have to cut goods or people or whatever with by land transport or air transport. Would that be the only reason why we're so bad?
So that's something that I've thought about a lot as well. And I'd be curious to know other people's perspectives as well. I have thought about that a lot. Australia is very big. I mean, obviously, I think our transport emissions would be quite high. We also have a very agriculturally intense economy as well, but they're generally more methane emissions rather than CO2 emissions. So our CO2 is still high. So it's also based on the fact that we have built cities that are very dependent on cars. So car ownership is very, very common. A lot of families have 2 or 3 cars. Whereas in a lot of places of Europe, you know, some have 1 car, some people don't have any cars, some people don't even have a license because you can just live without having to do that. We also, haven't got, I guess, really good intercity transport. So public transport, we don't have so in a lot of Europe, you have electrified intercity trains. So you catch a train to go from city to city, and that's on rail lines with electric power, like our metro network. So there must be a few factors at play there. I don't have all the answers, but I definitely think that's a contributing factor. But I don't think we should say, oh, it's just because Australia's big, you know, we shouldn't do anything else. We're probably not that bad. I think there are lifestyle issues and there are urban planning issues as well that are at play, I would say. But I'm curious to hear any comments on that, also from other people, if you have other ideas.
Just pick up on the things that gives you all the ideas what to do.
Yeah, that's a good point, actually. I'd just like to raise that there's been a lot of talk lately about our energy policies in Australia, and there's been blackouts in Victoria and South Australia and things like that. But there's the huge white elephant in the room that no one's mentioning is our energy consumption. We're still building houses with black roofs, no EVs, and boxes that need massive air conditioners to make them livable. So I think maybe a lack of innovation to make it easy, like the easier option to be and cheaper option to be building our buildings like that, and make it or harder or cost prohibitive to have these boxes that need air conditioning and heat, that kind of thing. I think there's a real lack of innovation and education and economic accessibility for the average person to build a sustainable solar passive house and look at our energy consumption.
Yeah.
There's a lot of lack of education. For most people that are moving into digital social housing, because probably not the resources to look into those areas. Certainly, black rooms and other rooms. I feel that could be innovative. Would actually legislate to make like back tiles and rooms that are make white rooms a cheaper option to try to discourage people. And I mean, these should be compulsory anyhow.
There's lots of little things. They seem like lots of little things, but I think together it can make real differences.
I think it's critical that we can't expect people to suddenly go, you know, when you go and talk to anybody, go and look at the houses over the inspection. I've got there. So what are your ecological, you think they'll say no, and I said, like, why? And they said, there's been no call for it. But government hasn't suggested to make it become viable and more sustainable. And people don't care. People, of course, don't know that they may.
I think there's obviously a role for greater engagement and encouraging people to make these decisions and empowering them to do so, but obviously a role for legislation as well. So we can have incentives through making certain things cheaper, but we can also just back certain standards. So we can actually also just say, well, we can produce 5-star energy fridges now. Why are 3- and 4-star energy fridges even legal? What's the purpose of having them in the economy? We can just make them all 5-star energy fridges. And
do you think it's a question of incentives, government, like pressure from industry and
yeah, I mean, we do live in a democracy, right? So if everyone just basically thought these same things, we could all just vote tomorrow or the election maybe in a couple of months' time, and everything would suddenly change. So it's a lot about political engagement as well, and empowering people to realize that they can, you know, create change to the political system. That doesn't just mean voting. That also means going out and running campaigns and encouraging other people to vote or to engage in on certain issues. I was just going to say one other point about housing, and then I'll take your question. An interesting insight from Sweden. In Sweden, it's very cold. I'm sure you know. They have central heating in most houses. It's actually quite energy efficient. In the UK, for example, there's a lot of leakages through window sills, and the UK has a very high, what do you call that, heating energy consumption. In Sweden, it's very low. But despite that, you can actually live in Sweden without any heating. You can build passive houses, and I've been to a passive house. They have very wide walls, and then just the body heat of people in that house is enough to keep the house warm. So you can actually build houses like this in Sweden, and people are, you know, some people are doing this. But there's this perception of, oh, these are expensive, or we don't need to do this. Oh, there's no incentive. What's really interesting though, is that all houses in Sweden, almost all of them have nuclear bunkers, because Sweden was this neutral country during the 60s, 70s, 80s, when they were, you know, just a few hundred kilometers away from Russia. Swedes were paranoid about Russian nuclear attacks. So every house you go, so usually in apartment buildings, right? You go underground and there's this giant labyrinth of, you know, titanium doors that you can lock in. It's crazy because this would cost a fortune. This would cost so much to make bunkers basically in every public housing apartment building. But it was considered a need, and so they just did it. If that level of resources was directed towards building passive housing, then all of Sweden would be able to do it as well. But it's not, because it's not a government standard. It was a government standard, which is a rule that everyone has to abide by. So it's a lot about, this is what I mean, it's a lot about our imagination and our perception of what we can and can't do. We can physically do all of these things. We have the technology, we have the intelligence and the resources to do so. But there's perhaps other barriers. I'll take your question, yeah.
You're saying how the Earth is using more than it could grow, and especially with water. A lot of countries are turning to reverse osmosis units from sea.
Yeah.
From what I understand, in the early days, I don't know if the percentage has improved, but for every 100 gallons you put through an RO unit, you've got 20 gallons of fresh water, 80 gallons of sludge.
So I don't know the statistics on that, but
50, even 50,
yeah.
50. They're pumping that sludge back into the ocean.
It's just insane.
But it goes back into the ocean as superstuff.
Yeah.
And so, and you've got countries like the United Arab Emirates, just about all their water comes from RO units. You've got Israel, massive units they've got in there. There was a show on TV just recently about it. And so if all that super saline water is going back into the oceans, there's got to be a point at some time where the ocean can't cure that.
Except that ocean already, that salt in that super saline water was only out in the ocean in the first place. It's not like it's being created in the salination process. It's only the salt that's been removed, so it's only going back where it came from.
But the salt level
It's
in the
not new,
ocean.
not new salt.
No, but the salt level in the ocean is,
3.5%. No, 3.5%.
yeah, 25,000 parts per million or something like that, yeah. Compared to 50% stronger going back into the water. So it's got to be a line.
It'll disappear within a few hundred meters of the outfall back into the ocean just because of the sheer size of the rest of the ocean.
It's just the same.
It's not changing the ocean because the water cannot be stored on land or in the atmosphere. The ocean is always stored.
The ocean has a certain level of salt.
Yeah.
You can't keep putting higher salt levels back into the ocean.
You're assuming that the fresh water then makes its way back there. It does eventually, and that evens it out. You're not increasing the salt in the ocean.
We're taking that fresh water out of the ocean
And you're
because we're only using it
going
coming up on land. So if we're pulling too much out of the earth.
I think we'll open this discussion up. Sorry, you had a question there.
Question or statement. You raised the example of nuclear bunkers, make the people put those in Sweden.
Yes.
There's a lot of money to do it. I think the reason is that people understand what happens when a nuclear bomb goes off, and the world on the whole doesn't really understand what climate change means, and so doesn't act. And, you know, we've all seen images of nuclear bombs and the terrible effects of that, but I don't think people can clearly identify, because there's so much science, and a lot of people just bombarded by the science, and it's important science. You know, the graphs are quite complicated, and I think it's hard for average people to grasp what they're saying in those graphs, in order for them to spend money to address climate change, where they would spend money to put in the market because they know what it costs.
Yeah.
That's probably the biggest challenge that we face.
Exactly.
It is clearly articulating to them what actually is going to happen. It's become politicized, and so that turns people away from electricity. So there's a lot of challenges it faces, but it needs to be a simple message what will happen to the world if we don't address it.
Yeah, exactly. And that's why these spaces and these conversations are really important. And they're important that they also spread outwards. There are other people with loud voices who say different things in regards to climate change. Well, personally, I'm quite shocked at the number of letters sent into the newspapers, basically promoting a climate skeptic point of view. Because the percentage of people who are climate skeptics or climate deniers actually isn't that high, but they're a very, very vocal minority. So it's important that majority or otherwise people who believe in the science, which is the far majority, also are vocal, because otherwise they will get drowned out. Because like I say, it's about changing our perceptions. That's very right. Once we change our ways of thinking, everything else rights itself. So we can change our prime ministers, we can change our taxes. These are often quite small changes. When we change our way of thinking, we're going to produce outcomes that are sustainable if we think that this is basically the basis for everything else, I would say. So that's, yeah, a very interesting point.
Yeah, I think what if people can't visualize something, they can't really measure the real cost of it at the end of it. If you can't visually see what's happening, then it's very, very hard to place your own sort of value of how important it is.
Also, a lot of the value is tied up in the future, right?
Yes.
The value of not having climate change is that maybe in 50 years' time, we'll have twice the agricultural yields compared to if we have climate change, which reduces our ability to undertake farming. A lot of the value is in the future. And a lot of the economic modeling that is used is based on discount rates. So discount rate basically says that $100 to me next year is only worth, say, only worth $9 to me today, because people value the things that they have now more than we value them in the future. So that's what a discount rate is. And a lot of economists use very high discount rates for things related to climate change, so often a 10% discount rate, which would be, so $100 next year is only worth $90 for me today. But then $100 in 2 years' time is only worth $83 for me today. And I just played around with the calculator to see when does this become virtually nothing. And I think after 50 years, using a discount rate of 10%, so something that's worth $100 in 50 years is only worth 50 cents today. And that's not taking into account inflation, that's just talking about the actual today. And this is quite dangerous because it means that nothing matters in 100 years' time, basically, if we're doing these discount rates. And of course, our climate modeling, a lot of the climate modeling sunsets, so you can't have models that run forever. There's too many uncertainties. But regardless, even where the science is unclear, the economics is making it irrelevant what the science says because it just has no value to us. Yes?
I'm just wondering if you go back to the all through model, which is not like a quantitative change, but I'm going to all through when politics happen as sort of flips, it goes over the kind of top into the group and then settles in there, and then you've got a system change where you can't get back over back to how things work. So if we cross the threshold, it's not like incrementally we can go back again. It's like we're not expected for a particular long time.
Yeah, so it always, all of these groove graphs or whatever we want to call them, stability domains are unique. So there could be another thing over here that looks like this, that looks like this. This is just a representation for these two coral reefs, right? So this one, it is kind of like falling down, but it's complex. And a lot of the time we don't know what these different states are. Another really good example is what we see a lot here are algal blooms in the rivers because we put too much phosphorus and nitrogen into the water, I suppose. They flow through the soil as a result of rainfall. And when we do this, there's a lot of undergrowth and there's a lot of, I think it's mud in the river that absorbs a lot of these chemicals, which means that we can have a certain part per million count of nitrogen or phosphorus and everything is okay. So we're not going into an algal bloom. But then once it gets saturated, what happens is that these sinks, so a sink is something that takes something out of the system. So the sinks of phosphorus and nitrogen actually become sources of phosphorus and nitrogen on the way back. So it's like you walk through one door to get somewhere, that door then closes. You need to take a different door to get back. And often it's quite a lot harder. And that's the case with what happens with algal blooms in rivers and lakes. In some lakes in parts of the world, they've changed. They're no longer clear water lakes. They always have algae there. And it's very hard to get the nitrogen and phosphorus back out. So yeah, exactly. The point I guess here is that our pathway to a certain destination is not the same pathway back. We can't just reduce our carbon and say, oh, well, now the Earth will cool again. Even if we remove carbon dioxide from the atmosphere, it won't just cool in the same pathway in which it warmed because of the feedback. So yeah, it's really important to understand these kinds of graphs. Yeah.
I think one of the greatest examples of value adding on for the future percentage of GDP growth, or whatever you call it, solar panels. I got mine installed in 2010. It's just paid dividends financially, and it's paid dividends from here. Personal satisfaction.
Yeah, and I think that's what really is quite heartwarming to see in Western Australia, that there's such a huge uptake of solar panels. And I think it's a good example because not everyone in the society is going to be an environmental activist. That's never going to happen. But when you create good enough incentives for people to see that this also benefits your pocket, that this also is good for you financially, then people take these kinds of things up. So it's about creating a good framework. So not everyone's always going to have that environment as their first priority. Yeah.
But one of the problems with the Australia-wide standards, so like with solar panels, there's different tariffs in all the different states. They seem to not be able to make up their mind about whether they want you to have it or not have it. They change the rules every 5 minutes.
The benefits change
Exactly. I went to, well, when Sustainable House was in Mineral Springs, I went there to one of the early panel sort of presentations, and it was very clear. Some people in other states are actually investing in solar, so you could have your self-managed super of a property was lined up with, and you could get, well, obviously very good financial returns. It was environmentally friendly. It wasn't supporting a tobacco company or a gambling company or some other company that's digging everything out of the ground. But that's not possible in WA, and we've probably got no sunshine. So there's a lot of very conflicting things. So I think we've got to have a standard. In Australia, we're not that many people, but we're having an enormous impact, as you pointed out. But we need standards. We can't afford to have all these different standards in different states.
Yeah, I agree.
Earlier we talked about not seeing the impacts now. We're not facing the impact. I mean, okay, that could be our thing too. But we're not seeing them as vividly as if we live on the island, the Pacific, getting small. Just a thought, if anybody wanted a little more proof today, there's a video that I just bought that was an old-fashioned DVD, but you probably might download it in other formats now, called Chasing Ice. And if people today wanted to see visible evidence of the impacts happening already, and this was a few years ago now, 3 or 4 years ago, the video was made. So remember that we're Chasing Ice. On Netflix. Oh, look, okay, there you go. I'm going to be available on other platforms now. I bought it as a DVD a couple of years ago.
And what I think it's important to reflect on that is that the warming, the melting we see associated with that is actually based on past warming, because we have a lot of delays. So what we're doing now is going to be creating further melting in the future. So there are these delays, and unfortunately that does blind us a little bit to being able to realize what's going on. But we're starting to see the effects of what was going on beforehand. So now we're going to see more also into the future as well. And then, of course, it's always hard to say that something causes something. Right? We've got a lot of, I didn't talk about, a lot of the floods we've got in Townsville, a lot of the fires we've got in Victoria, because nothing is 100% caused by climate change. Climate change is a driver, it's a contributing factor. It means it's more likely this kind of weather is going to happen. And unfortunately, when people say that, oh, here's your evidence, look at this fire, then someone will say, it was really cold yesterday, so therefore, this is my evidence. So it becomes this game, basically. So it's really unfortunate, and that's why it's hard to get people to understand the science, because it's more about drivers and underlying changes of what the base level is. But that's really good that there are some kind of clear evidence things. Ice is something that doesn't change very much, very often. So that helps. We can probably go for a few more minutes, I think. Yeah.
Just before I start, I just want to say, I apologise, I have to step out for a minute to the break. I missed the start of this second part of your talk.
No worries.
But I wanted to acknowledge your point about the economic treasury or the environmental ecological treasury. I think it's an absolutely killer idea. And it's one of the things, in my observations in Australia, that Australia's failed on. We have environmental laws, we have an EPA, but we seem to miss these opportunities when economic reasons overpower. You, in your lecture, I remember at one point you said that you seem to have a positive take on what our political masters are doing. I'm a little bit confused by that, because that's certainly not my perception in Australia.
In what sense do you mean? Was I being positive?
I can't recall the exact part of it where you were in the lecture, but I remember thinking that you sounded positive about our future from a political point. I wouldn't have that same take on the Australian political structure. And I'm interested to know how Sweden compares in a political sense to us. You mentioned before that Sweden's got different practice, I understand that, but politically, I'm very pessimistic about Australia's political future.
Yeah, so that's a really good point. There's a few things I will respond to. I guess firstly, it's important to treasure the institutions that we have. They might not be operating the way we want them to operate, but just the fact that we live in a democracy that we can encourage people to go and vote and that we can go and vote is something that a lot of the other parts of the world just don't have. There's no mechanism that they have whatsoever. And so I think our system isn't working very good, no, in terms of this. Otherwise, we would see us taking more action. But just the fact that we have the capacity to use these institutions for something good means that we have a chance of making things better. We just need to somehow find that power, find that voice. Unfortunately, at the moment, it's other people that are often more vocal. In terms of comparing with Sweden, it's also a really interesting point. Sweden's political system is very different for many, many different reasons. But it was interesting this summer in Sweden, so in the middle of last year, it was incredibly dry. The rain never came, and you might have heard about there were even fires up in the Arctic Circle, which doesn't really happen. Bushfires are very common in Australia. They're becoming more common, but they are a natural process. Fires in the forests in Europe aren't natural, they are destructive. Eucalyptus trees need fire, those trees die when they have fire. So it was very problematic. And a lot of people are talking about the climate. If you look at Sweden from a satellite image in July last year, a lot of it is just yellow. A lot of the crops failed, and a lot of, I think they got half the output they usually got. So this was really interesting. There were some really clear visual effects of what the science is saying is going to happen more in the future. There was an election only 2 or 3 months afterwards. So everyone thought this is going to be the climate election. People are finally going to stand up and really make this about the climate. The problem is it didn't actually happen. It didn't become the climate election. There's a lot of parties. So Sweden works on a coalition system. You have lots of different parties working together. And the environmental party were in coalition with the governing party, and a lot of people resented them because when you get into government, people say that, oh, you didn't do it good enough. And they actually had their primary vote reduced quite a bit. And unfortunately, another trend in Europe currently is this xenophobic trend, this potentially neo-Nazi trend. Unfortunately, that party claimed a huge victory in the election and destabilized the current way that Sweden's political system is working. So there's been a big trend towards that, which is quite scary. But I would say that what we are seeing generally around the world, when you look at the UK, you have Brexit, but you also have Jeremy Corbyn running the Labour Party. In the US, you have Trump, but you also have Bernie Sanders, who nearly made it. What we're seeing is we're seeing a destabilization of the status quo. People are fed up with the status quo. It's not working. They're sick of bureaucrats running basically the same old agenda all the time. They're looking for new voices. And unfortunately, they're going to both extremes. So they're also going to the xenophobic extreme. And I think it's important. This is a window of opportunity, if you think about that. There's a window of opportunity around the world in the political structures. We just need to make sure that it's claimed by an agenda that is more favorable to promoting our living conditions rather than one that's more based around other issues. I think we're on the hour now for 7.
Even one question?
Yeah, so we might just take one last one.
If there's no more questions, could I just say on behalf of all us, oh yes, although I'm not as old as me, how refreshing it is and how fabulous it is for us to see a young person from Canada saying the things you're saying and presenting this information to us. It is very organised, very quiet, but underneath very passionate way. We're absolutely privileged that you've taken the time out, and that not only that, the world is privileged that you and others like you are doing this.
Thank you. But it would be very different if I was just here in a room talking to myself. So I think it's important to recognize the number of people that came out tonight. And of course, we had even more people before. So thank you all for attending. We can keep these discussions going. We have another event. If you want to stay back and have a chat, I'll also be here. So thank you once again and have a great evening.